Hello everyone, welcome to the ISES webinar. I am Dr. Shahid Parvez, Assistant Professor, Indiana University. I will moderate this webinar. For those of you who are not ISES members, please consider joining the society as the society offers many benefits to its members. Please visit our website www.intelexposurescience.org to see the benefits of our membership. A few quick housekeeping notes before we get to today's presentation. In the upper right side of your computer screen, you will see a control panel. Please note that this webinar is listen-only mode. Submit your question in the chat box. You can type in a question or comment and submit it at any time during the presentation. We will have time for Q&A at the end of the presentation. So today's speaker is Dr. Rama Chari. Dr. Chari is a policy researcher at the RAND Corporation. Her research focuses on environmental and social determinants of health, occupational health, and environmental risk assessment to inform public policies. Dr. Chari received her MPH and PhD in health policy and management from the Johns Hopkins Bloomberg School of Public Health. Dr. Chari will be discussing a career path for performing research intended to inform public policies and lesson learned, and will also describe challenges and opportunities for researchers. Dr. Chari, it's over to you.
Thank you. Hi, everybody, and thank you to Shahid for inviting me to speak and for that introduction, and thanks to all of you that showed up today. It's really exciting to see interesting careers in this area of research for action. And so as Shahid mentioned, I'm a policy researcher at the RAND Corporation, and I have an educational background in risk and exposure sciences. So the first part of the presentation will really be to give some more background about me and my career path, to give you some context as to at least one path to a career at the science policy interface. And as evident in the title of my talk today, I will present my perspectives on working at the crossroads of science and policy, and particularly doing research in this area, and then really trying to translate exposure science or science in general to public health and public policy actions. So from the description for this presentation, I had listed two main learning objectives for the session. And so in the presentation, again, as I mentioned, I'll discuss the career path for performing research intended to inform public policies and some lessons learned in pursuing this area. And then the session will also cover challenges and opportunities for researchers who are interested in translating exposure science research into actions. Now, my particular work and interests will, of course, not be directly relevant to everyone. So where possible, I try to be more general in deriving lessons learned. But if there are specific interests that any of you listening have or would like to pursue that aren't reflected in my talk, please feel free to ask questions or make comments, and we can share and discuss in the latter half of the session. And so as you can see on the screen, we have a four-part agenda for the session. First, again, I'll provide some background on me. And remember, this is an N of 1 in terms of experiences, and there are multiple paths that one can take to a satisfying and hopefully long career doing applied research. And second, I will talk a bit about what I think it means to do research at the science policy interface. And so really what differentiates this type of work from purely academic research or from basic research, and what are some of its defining characteristics. Third, I'll briefly note why I believe this type of research is important and necessary, and why its importance will only grow in the future. So in short, we really need more researchers willing to work in what can sometimes be a messy and frustrating, but ultimately insanely rewarding area, I feel. And then finally, I'll end with some concluding thoughts on things I wish I had known before I was really thrown into doing the work I do, to provide some tips for those of you who might be interested in learning more about or pursuing a career in science policy research. So let's begin with me and my career path, or my attempt to present to you my bona fides. So apart from my very early years wanting to be an environmentalist and then a private detective and then an FBI criminal profiler, I think I really started my career in in pursuit of a liberal arts degree at Middlebury College. While I was there, I majored in neuroscience, and I found, that first metaphorical fork in the road as I was working in a lab, researching the role of different proteins in regulating circadian rhythms in mice. And I found that, I really did love this research, and I loved the thrill of seeing hypotheses pan out or not. But ultimately, I found I was more interested in the implications of the work we were doing. And so, what could circadian rhythm research lead to? Or how could this work lead to any applications? And so from college in Vermont, I then headed to Washington, D.C., and to a job at the National Academy of Sciences and the National Research Council's Board on Environmental Studies and Toxicology. And at the academies, this was where I was very much first exposed to the use of science for decision making, as the academies would convene these groups of scientific experts to review evidence around a topic that was often, defined by Congress. For example, for one of my projects, the then Senator of Alaska, Ted Stevens, felt that Fairbanks, Alaska should get an exemption from the Clean Air Act's National Ambient Air Quality Standard for carbon monoxide because of how difficult it was for the city to meet the standard, given its unique meteorological and topographical characteristics. And therefore, a committee was convened to determine if that should be the case, what options Fairbanks had for meeting the standard, what the implications would be if the city did not. And there were many, many committees that were tackling issues such as these. And so, to anyone on the outside looking in, you might, wonder what the big deal was with the academies. There's a bunch of distinguished looking older men and women sitting around a table talking for hours. And there's me whose job really was administrative. So first and foremost, I had to make sure articles are photocopied, distributed promptly. Everybody had their lunch and dinner meals, hotel rooms were booked. But, I really loved being in those rooms, knowing that the people in there were discussing these issues that could affect the health and livelihoods of millions. It felt like this was really important stuff. And so from there, I decided then to pursue a master's of public health and then a degree in health policy and management at Johns Hopkins Bloomberg School of Public Health. And there I specialized in environmental health policy and then in risk and exposure sciences. During the program, I got internships at EPA and the Environmental Defense Fund. And so from there, I was able to learn about how science is used in academic settings, how science is used in government settings, and then how science is used in advocacy work. And this is probably what solidified my interest in this crossroads area of science and policy, because I could see how scientific methods, the design, the principles, like these things, they might not change, but the idea of science existing in a vacuum and revealing the quote unquote objective truth of a matter didn't really seem to be the case. It seemed like the settings in which science was performed could really influence how science was done, the kinds of questions asked, the people doing the asking, the results that would be emphasized, and conversely, results that would not be emphasized, the assumptions that might be used in analyses or models, whether to rely on p-values, et cetera. And I'm not trying to say that, in academia, government, or advocacy worlds, that one setting, was doing science right and others were not. They were all doing it right. This was all high quality, rigorous research. Yet the use and the communication of scientific results could really differ. And so that intrigued me as well. And so then when I graduated from Hopkins in 2011, I headed over to RAND in Washington, D.C. as well. So, some of you may know about RAND already. It seems to me we have a more pronounced reputation in healthcare circles and also in defense research. But RAND, does research in many different areas, including public health and environmental health, which are my fields. And, RAND is a nonprofit research organization that conducts research in the public interest. We pride ourselves on quality and objectivity, and we are nonpartisan. I've heard some people refer to us as the original think tank, and we do share characteristics with think tanks, although without having any kind of political lean. But we also share characteristics with academic institutions. We have a graduate school program that awards PhDs in public policy, and we also share some DNA with consulting firms as well, I would say. And so this slide just really shows RAND's geographic reach with offices throughout the US and in Europe and Australia as well. So one thing that really appealed to me about RAND coming out of grad school was that I knew I wanted to do research, but at the time I also knew I didn't want to teach. And I saw RAND as the closest thing that you could get to academia, without having to teach. And the other thing that really appealed to me about RAND was this mission to perform research to improve public policies. Therefore, we only do applied work at RAND, and as opposed to being evaluated on things like the number of publications, RAND researchers are evaluated on impact. So how our research has contributed to decisions or actions taken at local to national to international levels. And so the overarching objective of all my work, I would say, is really, to put it simply, is to help. So whether it be helping one small community organization needing guidance on some environmental health issue, or a policymaker at the national level seeking to implement some wide-reaching legislation. And so, what makes research then to inform decision-making or actions, what I also call action-relevant or action-oriented research, different from other types of research? And so other types of research might be research to increase basic knowledge, such as the work that I did in circadian rhythms and understanding how different proteins might be involved in biological processes. There's also research to investigate a problem or understand associations. I just came from a meeting where we were brainstorming ideas for assessing exposures from contaminants in e-cigarettes or vaping, right? And so this might be an area that is very early, and so the scientific applications might not be clear, yet the research is extremely important. And so, at its core, then, action-oriented research is research that's really designed to inform actions. And I list a number of examples of different types of actions that, have come out of some of the work that I do, such as developing interventions and policies, designing program or organizational processes or structures. Evaluation is a big part of our work. Changing or updating clinical guidelines, informing legal cases or product design, strategic planning, creating educational materials or approaches, and I'm sure there is much, much more. And I also wanted to point out here that the exposure and risk sciences, to me, are really true exemplars of science for decision making, and even more so today. In the past, there were calls to separate risk assessment from risk management, so that risk assessors wouldn't be biased by decision maker needs. But in more recent years, right, there are these calls for integration of risk assessment and risk management to ensure that the work that risk assessors do is actually relevant, it's usable, it's transparent, so that you could actually make decisions. So this idea of science, being up on a hill, untainted by the needs and desires and politics of the people, that really only works, I think, if your goal is to contribute to general knowledge and do basic research, which is very, very important. But if you need to make decisions, I think you need science to come on down from that hill and really be working in the trenches right alongside you. And so on this slide, to give you some more concrete examples, I've summarized the breadth of work that I do or have done at RAND, and it covers many different content areas and also many different scientific methodologies. And so I won't go into details on any one project, but starting from the upper left is a study funded by the National Institute for Occupational Safety and Health, and upper left being the picture of that Superstorm Sandy. And this was a study to characterize community and recovery worker exposures following Superstorm Sandy in New York, characterized their exposures from what we call fugitive chemicals or chemicals released from industrial facilities and then dispersed into community or public spaces because of flooding or storm surge. And so, we did a exposure assessment approach for this. The next picture is of the oil spill or a chemical spill is work that we're doing in Sunset Park, New York on developing a community-based intervention for small auto body repair shops in Sunset Park, Brooklyn, New York. And so we are using a method called community-based exposure assessment to help inform the development of this intervention. The next picture is of the World Trade Center, and this is, again, a NIOSH-funded study that is helping the World Trade Center Health Program perform strategic planning about where to go with its research program, which I believe has been funded out to something like 2090. And so the idea is to understand how their research is being used and translated now, and then again use that to help inform their strategic planning needs. The next two pictures, there is a colorful picture of radiation maps, and then on the bottom left-hand corner is a picture of community members who are learning how to test soil samples for oil contaminants. These are representative of some of my research on citizen science, which is citizen science being the proliferation of non-professional scientists or members of the public engaging in scientific research methods to measure the environment and ask and answer questions about the world. It's an emerging topic, and we are trying to figure out specifically how to develop collaborative models for citizen scientists and local health departments to work together around disasters. And then finally, there is a mix of some other work on occupational health and well-being, national health security, and then doing some work on incorporating measures of climate equity into evaluations of climate change policy proposals. And so this is just trying to give you an example of some of the quote-unquote action-oriented research that we do at RAND. And across these myriad project types, I also employ a range of quantitative and qualitative methods, including exposure and risk assessment, participatory research methods like community-based participatory research, epidemiology, evaluation methods, qualitative methods like interviews and focus groups, thematic analyses, and then stakeholder engagement methods like priority setting exercises and expert panels, and then survey design is a large part of what I do. So I just gave you a lot of different examples of science policy research, and in thinking over the overall body of work, I tried to figure out what the common threads might be when doing work that is meant to lead to actions to impact. So think about how you go from research to action. And I think the real hallmarks of this work are evaluation, translation, and engagement. To effectively translate, you must evaluate the research that you do so that you can course correct or make it better. To effectively translate, you must engage with different stakeholders that even at all points of the research process, from the design phase to the dissemination phase and even in between. And if you do all that well, you can have real impact. And when we talk about translation, we really mean making sure research is relevant, it's usable, and it's transparent. And so I also want to note, I'm not sure the background of everybody on the call, but if you currently do more basic research or are more of a lab researcher, there are also ways to integrate the principles of action-oriented science into your own work. So it's not the case that, one has to forge a road specifically focused on action or policy-oriented research. Instead, I think you'd be ahead of the curve if you simply start to look at your own work and think about and learn the larger context about what you do and why. And that is really the first step to understanding the relevance of what you do for the larger world or for different stakeholders or end users. And then knowing that will naturally make you a better communicator and translator of your work. And so, you can ask yourself, who would use my research? Why would they need it? How will they use it? You should ask, who would my research affect? Which is not necessarily the same as those who would use it. And then knowing even, the larger context of your work, including, who is funding you and who are your funders accountable to, right? Who's driving the research questions? Did it come from a request for proposals from the funder? Did it come from you? Again, just always thinking about your own work in a larger context will automatically prime you to understand more how to translate that into action. So, this slide really tries to get down to, why I think this type of research, action-oriented research is important. And first of all, I see a number of trends that are happening in society today that may increase the utility of and the demand for this type of work. And so, for example, we increasingly see this phenomenon happening. Rand calls it, quote unquote, truth decay, or the questioning of facts or scientific evidence. We're witnessing the encroachment of politics into science. And at the same time, there are these incredible technological advances, which are spurring movements to amass and research big data sets. It's helping to speed up the dissemination of all types of knowledge, even if scientific knowledge, might not be ready for application. So all this to say, if the public does not understand the scientific process, if they're not involved with the process, they may tend to grow suspicious of it. So we're also seeing these trends towards citizen science, with communities taking advantage of new technologies to measure their environment, to share things with others. The scientific world itself may be changing with the growth of the open science movement to make the work that we do and the processes we use, like peer review, more transparent and accessible. And then finally, all of this is happening as the world is experiencing growing large-scale problems like climate change and income inequality and political unrest. And so to me, action-oriented research where the work you do is relevant, it's usable, it's transparent to different stakeholders and different audiences, and is designed to address complex societal problems, it grows more important in this rapidly changing society. And at the same time, funders increasingly want impact, and they want to see returns on investment. And we are especially seeing this with foundations. And so perhaps, the only way to ensure that decision-making and actions are evidence-based is to engage directly with stakeholders to understand and mitigate any barriers to the use of science for decisions or for actions. And so instead of thinking about science then as being up on that hill as something that is objective, it must be kept above the mess so it's not tainted, like those of us who work in the science policy interface, we jump right into the fray and try to make science work for the communities that it's meant to serve. So for example, I had a project which I talked about a little earlier in citizen science, and specifically it was to help develop a citizen science oil spill monitoring program in Louisiana. And part of the training was for community members to go out to gather soil and water samples, and then we would all get together and test the samples. And so trainees in this pilot program, they went out, they gathered samples from places they were concerned about, like church playgrounds and backyards and schoolyards. And when they tested, they found that levels of oil contaminants were actually pretty low. And they were shocked because the assumption was that essentially there was oil everywhere. And so we asked them, what if EPA or what if Louisiana Department of Environmental Quality, what if they used the same testing kit, they did these tests, and then they came back and told you the results, that there were low levels of contamination that were found? Would you have believed them? And all the trainees said with zero hesitation, no, I would not have believed them. But they did believe the results that they themselves had taken. And so, situations like these, I think, really underscore that we really may need to be thinking about new ways to do research to make sure it's effective. It's not simply about talking to ourselves in our ivory towers or in large research institutions, writing papers for each other, but, and all those things are important. But finding ways to translate the science itself to new audiences and then building their capacity to take part. Another example is the work we're doing in Brooklyn, New York on fugitive chemicals. I forgot to mention that work is funded by NIH, National Institute of Environmental Health Sciences. And we're using a method there that we're calling community-based exposure assessment. So the idea being that any risk or exposure model we develop to address local level concerns will be inadequate to that task without having local level data. And then any risk estimates that come out of those models will be ignored without local community buy-in to the process itself. And so, a sentiment that was relayed to me by our community partners in this study is that they're sick and tired of being studied to death. And so the folks that we're working with, UPROSE is a community organizing group in Sunset Park. We're also working with the New York City Environmental Justice Alliance. And our third partner is the Lifeline Group, which is a exposure and risk modeling organization. And the model that we use for this research is an equal partnership among all organizations, with everyone contributing to research tasks, and really every task. So if a partner does not have an existing skill set, like performing data collection, instead of the research organizations just taking that on, we are teaching the skills to our partners so that they build the capacity, so that they are the face of this work and the face of the intervention in the community. And of course, this learning and capacity building is multi-directional. So I've certainly learned a lot and built up skills in CBPR through this partnership. And finally, even work like the World Trade Center Health Program strategic planning, there are vocal and passionate survivor groups from 9/11 that actively question the research that's being done, the types of questions that are being asked and answered. And so it's really, really important, therefore, for a program like the World Trade Center Health Program to ensure that the research that it funds and supports and carries out truly does get communicated and translated to different audiences, or else you could get this atmosphere of fear and distrust over the research, and whether or not it really is relevant to the people who it affects. So finally, the last thing I wanted to bring up was essentially things to know to pursue a career in science policy, or what I wish I had known earlier. And so when I came into this space, I had a big learning curve of how to do this type of research. And the first thing is knowing like who does this type of work. And it was a broader range than I had initially thought. And so besides RAND and other research institutions like RTI or something like that, you'll find this type of work being done in academic institutions, in the federal government, of course, in state and local governments as well, especially the bigger and more well-funded local government groups. To some extent, consulting firms like ICF or Ramble Environ carry out work like this. And then, of course, the advocacy organizations like Environmental Defense Fund or Natural Resources Defense Council, they also carry out high-quality research. There's also a lot of energy at the grassroots level, which isn't an area that I had heard much about when I was in grad school and coming out. But groups like the New York City Environmental Justice Alliance or even UPROS, like they have ties to academic systems in New York City, and they often act as a stepping stone for young people who may move on to pursue higher education. One member of the New York City Environmental Justice Alliance who was on our team for our NIEHS grant was in part inspired by the work that we were doing and decided to go off and pursue a PhD, and he got into MIT, and which is awesome for him, and I really hope that eventually he comes back. But but that is definitely an area which I think is growing, and like I said, it has a lot of energy. Secondly, who funds this type of work? So, most of my work is a mix of government grants and contracts, but I've also been funded by foundations and, by groups like the National Academies, who were given funds to disperse as research awards after the BP oil spill. There is untapped potential, I think, in the private sector, and these days by individuals or philanthropic donors, which kind of leads us to the skills to build, or skills that I wish that I had coming in. And so partly when you're pursuing funding, the easiest to pursue are the large grants and contracts. These aren't the easiest to get, but the easiest to pursue because there are established channels of proposal writings and things like that. For pursuing, smaller foundations, private sector individuals, this all requires more boots on the ground approaches. So learning how to develop concept papers and ideas, how to pitch and sell, like how to market, if you will. And so I would have loved to have known more about the field of marketing and selling, which goes hand in hand with communications in general. Knowing about health and risk communications, marrying that with storytelling to know how to capture people's attentions is a really great skill set for this area, which would also help with partnership development, which again, I just went into cold. If I could go back in time, I would have taken classes in economics, in evaluation research methods and survey design, and I definitely would have paid more attention in my qualitative research class. These are all skills that I use on a daily basis now, but they did require a big learning curve. And then finally, places to go and people to meet. I learned a lot from my internships at EPA and EDF. It was a great way to explore different areas. I tell people a lot that if you're in the DC area, to take advantage of the national academies. There are many events there. There's lots of open committee meetings, sessions, or workshops, many of which are webcasts if you aren't in the area. These are things I wish I had taken greater advantage of after I left the academies, but they are a fantastic resource and a great place to network. The Research to Action program at NIEHS is another wonderful resource for learning about community-driven type of research. And I think that was all on my list. I'm sure there are many others to pursue. So that is the end of my talk. I'd like to thank you all again, and I'm happy to answer any questions or hear any comments.
Thank you, Dr. Chari, for your presentation and sharing your experiences. I guess we have a bit of time for questions. I think we have some technical difficulty. I realized that participants are not able to type in questions under question tab. So can I ask you to type your question in the chat box? It is right underneath handouts. So as we receive some questions, I have some general questions, sort of, from career point of view for our participants who are right now in the job market or about to finish their master's or PhD or even undergrad for that matter. So what kind of areas? So you talk about the kind of work you do. It is obviously very interdisciplinary and require expertise in different disciplines. I just wonder, what's the place of professionals and new researchers who have PhD in hardcore biomedical science or laboratory science? Do they have any place in consulting firm or other private sectors where they can apply this knowledge?
Yeah, I definitely think so. I mean, so much of this is dependent upon what your specific interests are and how far you want to go with applications, or what you want to apply the scientific skills and knowledge to, right? So if obviously if you're a biochemist and you go into the drug industry, then you're doing applied research and trying to develop and design drugs. And to me, that is definitely an example of applied research for product design. But for things like that, in terms of knowing the larger context, if folks are interested, it's also nice to be aware then of the larger policies that govern the work that you do. And so also knowing about FDA and various like healthcare policies that might come down the pike is going to be really influential in the work that you do, and conversely, the work that you do can influence those things as well. I think for a place like RAND or shops like RTI that are very, very focused on the policy world, somebody coming in with a hard science background would be part of a larger team, and all of at RAND we all do work in teams because nobody has a lock on every discipline, right? And so we need to bring in people with different perspectives and different expertise. And so having a hard biomedical science background is not a detriment at all into going into a field like this, as long as you're a team player and you're able to apply those to various settings. But I find like the folks who tend to not do well at a place like RAND are ones who have a specific interest and are really interested in pursuing that specific interest, because you need to be you need to have a little bit more of a generalist kind of perspective to survive at a place like this, to, you know, be able to adapt your work maybe to different contexts, or, you know, see how your work might be applied differently. And so, you know, folks who come in with very specific expertise and aren't able to make those connections, you know, end up, you know, not having a great fit at a place like this.
Okay, thank you. So I guess the follow-up question I have, I'm just curious, you know, I'm being in academia, my day look very different in terms of, you know, the dynamic workflow goes. So I'm just wondering, in consulting business, based on your experiences, can you talk about what are the common challenges that you come across in your day-to-day job?
Sure, and you know, honestly, like a lot might be similar. You know, anybody who works in a soft money environment would have to be flexible enough to need to go where the funding is, to always be aware of grants and opportunities, and to be, you know, trying to write proposals and basically fund yourself in a way. So I think, you know, so day to day there's always this bit of uncertainty, which I think, you know, kind of covers my day. And that uncertainty can be frustrating, but it also it keeps you motivated to keep working and keep striving for things. And so, you know, the number one thing I would say is uncertainty. Even when you get funding for a research project, that funding is going to last 1 year, 2 year, you know, 5 years, and then it's over. So you constantly, you know, need to be building your resume. You need to be publishing. You need to be disseminating your work in order to make sure that you can continue to have that work. I think some other common challenges, honestly, is staying fresh in a way. You know, sometimes we get our research grants or contracts in, and then, you know, we can tend to coast on them. Like we get a data set, and then, you know, from that data set we're able to publish a number of papers, and then you kind of lose, you know, maybe that initial inspiration, like what sparked you to go into the research, because you kind of get caught up in smaller and smaller questions, as opposed to always seeing that bigger picture. And so I think that's a challenge, is keeping that bigger picture of why you're doing what you're doing and what you hope to accomplish, and, you know, what your personal mission is. It's something that's very important and very pertinent to this work, which can be very individually driven in a way when you're pursuing your own kinds of research interests. And then I think there's just the daily challenges that we all have of, you know, multiple meetings and, you know, no time to actually do your work and that kind of thing.
Okay. So finally, I have a couple of questions. So the first question is, I don't know who is the sender, but the question is, what type of background experience is needed for graduating students in exposure science to find career at an NRO like RAND? Is a postdoc expected?
No, a postdoc is not expected. I came in straight from my PhD program. And so, you know, I think the fact that this is more applied research, you know, there is less of an emphasis on things like postdocs. You know, publications are always important when you're doing research, but, you know, at a place like RAND, I think there is a bit less of an emphasis on that versus academic institutions. When I came in to RAND, I think I had like maybe 1 or 2 publications, you know, and I did not have demonstrated grant funding either. And so, what you would want to do if you're coming in with a background in exposure science to a place like RAND or similar places. I think it's important to demonstrate that you have a mastery of your particular field, and that you understand and are interested in the policy applications of that field. Coming in, I had to do a job talk about my research, and a lot of that was, what are the implications of this work, right? Like what are the policies it's meant to influence? Like, who is this work going to be used by? Like that kind of thing. And so having a really good understanding of how your research could be translated and used, I think is the most important thing to demonstrate when you're interviewing for positions like this. And then depending on the shop, having that kind of flexibility, being able to work in a multi or interdisciplinary setting, and kind of demonstrating that you're a team player, are also really, really important attributes for carrying out this sort of research.
Okay. The second question I have is, as a new researcher, I don't know all the funded application, or I think it's like the possibility of funding application. How can we check what institutions have some international corporation or funding available? I'm from Latino America. Do you know which website could I visit?
That is a great question, and I wish I knew the answer. There was this one giant database which lists like every possible funder. I mean, again, this might depend on your research areas, but for U.S. funded research, there are a few go-tos, like grants.gov, of course, for federal funding. I think there are places like the Foundation Center releases or has a directory of funding opportunities from foundations. Actually, not just U.S. I think international as well. And so that's a great resource. I would definitely check out the Foundation Center. And then places like that come to my mind, like the World Bank, which might be more economics focused. But to be honest, I'm really not clear for international research specifically, what the major databases might be, or even if they exist. And if they do, they probably don't exist for environmental health and exposure science, unfortunately. But I would definitely check out Foundation Center.
Do you know of any national, like US-based organization that fund international research?
So I think the NIH Fogarty Center does fund international proposals, but other than that, I'm drawing a blank right now.
Okay. So the next question I have: how many projects do you typically juggle at a given time?
That's a great question, and that definitely is dependent or time dependent. Right now, I think I have five projects, and this really, so part of this is at RAND, we need to cover ourselves, and so everybody, we're 100% soft money environment, and so each individual researcher has to go out for grants and contracts and basically find their own coverage. And so either you do that by going out, writing and hopefully winning your own proposals, or you internally network with other RAND researchers so that they put you on their projects. And that's essentially what everybody does at RAND. It's some mix of your own projects and then other people's projects, which is nice in a way because it means we have a very flat structure. So, no matter how senior you get, that at some point you're going to be dependent on the new person, the junior researcher coming in, that you're going to need them to put you on their project. So everybody is very nice to each other. But that does mean it really depends. Some projects can be really big, right, in the millions of dollars, and it can fund a lot of your time. And there are researchers at RAND who might have like one or two like NIH R01s, and then they're pretty much set for 5 years. And then other folks, especially those like me in the public health world, I would say it's a little bit harder because our grants tend to be less money, and so we need more of them in order to cover all of our time. And then it really makes a difference too whether you are interested in just working in the grant world, or if you also want to work in contracts as well. And so contracts are also smaller money. And so I would say I've ranged from anywhere from juggling 4 projects at a time, up until 7 or 8. And then at the same time, you should always carve out some time to be writing proposals and coming up, or giving yourself time to come up with new ideas.
Okay, so we have this last question. Do you work with science communicators to reach out to communities of concern?
So I'm not sure if science, and if whoever asked this question, would like to be more specific, if that is a kind of a specific, position or person that exists to try and help bridge the gap between researchers and communities, or if you mean science communicators more generally.
I think he or she is referencing to media.
Oh,
this is my. I'm just interpreting this way. This is my guess. So I guess.
Yeah. So.
Go ahead. Sorry.
Oh, I was going to say. So I mean, so our work with media tends to be not so much on the front end when you're trying to develop partnerships or do outreach, but more on the back end of trying to communicate and disseminate. And on that end, we do like researchers will do interviews with reporters. We have an Office of External Affairs that helps to coordinate any kind of media approach or any kind of communication approach that we might need. A lot of the work we do with local communities, I think, is very it's very individual researcher based. It's important. There's a lot of trust building, I think, that has to go on when you do this type of work, and that trust building can take a lot of time. It certainly did, when I first reached out to the groups in New York City. It's not something where you contact somebody and then a week later you're writing a proposal. There could be people who are suspicious of you. It takes a lot of time, and so initially I think it really is incumbent on the researchers to be developing those relationships, and then when it comes to more of that like larger scale or wider dissemination of work, we do like work with media or I guess science communicators to try and translate our own work for others.
Okay. Well, thank you, Dr. Chari, for your presentation and answering all these questions. With that, thank you all for participating in this webinar. Shortly, webinar participants will receive an email from ISES that includes a link to an evaluation form. Please take a minute to provide your feedback. This recording of today's webinar, along with any handouts discussed, will be posted on the ISS website in near future. We hope to see you all for upcoming webinars. We will send out a notification to members once registration is available for our next webinar. We hope to see you all at ISES 2019 annual meeting in Lithuania in August. With that, thank you all.